Hello everyone, this is Dr. Daniel Barth with Astronomy for Educators. This week's activity, we're taking a look at the Earth and the Moon that orbits around it. We've all been taught that the Earth spins on its axis and that the Moon orbits the Earth in space. But do your students really know? Ask them this question: how do you know the Earth spins? How do you know the Moon's in orbit? Chances are they've learned, believed, and are ready to repeat what they've been told, but they don't actually know. This week's inexpensive and fun activity will address that. I always prefer when my students discover and then own knowledge. It's more personal, it's more engaging, and certainly it's a lot more fun. So let's take a look at our simple activity today. We're going to be watching the Moon in orbit. As I'm posting this, it's just about new moon on August 9th in 2020, and you may have one of these, a compass. But if you don't, you probably have one of these, which is a smartphone, and almost all smartphones have compass apps available for them. Even if you're teaching young children, this is an excellent opportunity for parents to get involved and help their students by using the compass app on their phone. What we're going to be doing is we're going to try two activities. On the first, we're going to watch the moon move over several hours into the west as it sets. If we think about this, what we're actually seeing when the moon sets in the west over a single evening, we're actually experiencing the Earth's rotation. The other thing we're going to be doing is we're going to be looking at the moon's position several days consecutively from around new moon, and you can check any calendar or web resource to find out when that is, and check the moon's position over the next several days, and this will show us the moon moving in orbit around the Earth. Let's take a minute and look at some resources and how we record this data. Now, here you'll see that I've taken a single piece of construction paper, the 12 by 18 inch variety, and I've split it in half into two pieces. I've made a graph, and this graph on the bottom shows azimuth or compass direction from 270 degrees west, 180 degrees is south, and we go over toward the east here. On the vertical axis, this is altitude, and this is the number of degrees off the horizon, and you'll see that we see 10, 20, 30 degrees. Now you might be saying, gee, how can my students measure altitude in degrees accurately? Well, if you have a ruler that measures, centimeters, if you hold a ruler at arm's length and you put the 0 on the horizon, each centimeter measures approximately 1 degree. Now, in reality, the ruler to do this precisely would need to be 57.3 centimeters away. By a happy coincidence, most people's arm reach is about 52 to 60 centimeters, and even so, it doesn't really matter much as long as the student holds it extended at arm's length each time as they measure. Their answers will be consistent. So we can measure altitude with a ruler, and we can measure azimuth with either a Boy Scout type compass or a compass app. You'll notice this graph says 1 night's motion. So if we start about 1 week after the new moon, what we'll find is that in the evening, the moon will be, and it's late summer, early fall, so the moon doesn't get above about 30 degrees above the horizon. We'll see that, the moon starts out in the evening right about here. If we're going to be really fancy, if we're starting 1 week after the new moon, we'll be noticing that the moon is in first quarter. It's about half illuminated. If we watch each hour, and again, it doesn't precisely matter what exact time it is, we're just going to record, we'll write it right down on here. What we'll notice is that during each hour, the moon in fact moves further westward and closer to the horizon, and we can go ahead and record the data right on our chart. So we can record the time. Let's say this was 8 p.m. Let's say this was 9:05, and so on. We can measure the times and we can record the date. And if we're measuring, we're going to get this lovely westward curve showing that the Earth is actually rotating from the west to the east. Think about if you were on a carousel, a merry-go-round. If you are moving to the left, everything standing still on the ground around you seems to be turning to the right. Much is the same here. What we're actually documenting with the changing position of the moon over a single night, over a few hours, is we're seeing the Earth's rotation. Now again, we can start this pretty much anytime during the waxing moon, the 2 weeks after the moon rises, and we can simply record our azimuth directions down as we move along. Using the same type of chart, and by the way, friends, what I've done here, for the azimuth on the bottom, every 1.5 centimeters, I've made a mark. That gives me enough distance in azimuth for anything I want to do. And here I've gone up 1 centimeter marks, 2, 4, 6, 8, 10 degrees, 20, 30. By spacing it every 5, it makes every mark 2 degrees, makes it really easy to measure. Now what's interesting here, we're going to get something very different. Because if we take a look at the moon very soon after new moon, we'll find that in the evening it's low and in the west. Now the important thing about this daily position activity, we must do it at the same time every day, as precisely as we can. The second day, we'll notice that the moon has climbed a little bit, and each day the moon will move westward and higher in altitude, and as we move along through the month, we will find that we get this lovely curve, not to the west as many people expect, but actually the moon orbits from west to east, the same direction in which the Earth spins. We call this prograde motion. And your students can measure and record this daily motion. If we're measuring it every day at the same time, what we're seeing is the moon's progress in orbit around the Earth, as opposed to the other graph on a single night when the moon doesn't move that much over just a couple of hours. We're seeing the moon sink toward the west because the Earth is rotating. These two fun activities, which take very little time and students can do independently in the evening with mom and dad, a great chance for parent involvement. These graphs also make a wonderful presentation when you have a back-to-school night. Now, if you'd like to do this activity at school during the time of waning moon, from full moon back to noon when the moon is shrinking each day, you can actually do this at school first thing in the morning because the moon will be visible in the morning sky. So you can do this activity at school if you'd like. Doing it in the evening, an excellent chance for parent involvement. I hope you've enjoyed this. This activity is based on the Astronomy for Educators textbook, which is a free open educational resource. It's available to you. Put Astronomy for Educators into any search engine and it'll pop up for you. You can also write to me if you have questions about this curriculum at astronomyforeducators@gmail.com. I also have a fully illustrated curriculum guide for this activity, which I'd be happy to send you. Drop me an email and I will send you the curriculum materials back, complete with printable worksheets and full instructions. I hope you'll like and subscribe to our channel. This is Dr. Daniel Barth for Astronomy for Educators, wishing you clear skies.